Problem number 7-6. Find the eigenvalues and eigenvector of the given matrix A. Matrix we have 3, 2, 1, 2 and we have 4 options. Now this problem number 7-6 is just our previous problem. We will use short trick for 2 cross 2. So what we have, first we need to calculate our characteristics roots, which is characteristics matrix, which is A minus lambda I. We got characteristics equation as A minus lambda I equals 0, and now we got value of lambda as 1 and 4. Up to here the process is same. We have to calculate lambda. There is no shortcut for lambda. Now whether our matrix is 2 cross 2 or 3 cross 3 and so on. Procedure for eigenvalue lambda is same. So we don't have any shortcut for calculation of eigenvalue now. But in the case of 2 cross 2, we have one trick to calculate eigenvalue directly. We will use that trick. From step, we will use lambda is equal to 4. Now consider a minus 4i into x is equal to 0. Then we have our matrix as minus 1, 2, 1, minus 2 into x1, x2, which will be equal to 0, 0. Now we will take a note from a minus lambda I. We can take either first row or second row, any one row. We can take either this row or this row for our next process. Now equation becomes we will use by using first row. We will use this first row. Our equation will become minus x1 plus 2x2. This is minus x1 plus 2x2 will become 0. Now we separate. Now we separate variables. It will be minus x1 equals to minus 2x2. It will become x1 by minus 2, which will be equal to x2 into minus 1. What we have done is we have cross multiplied. And if there is any cancellation, we will do, but here we do not need. Now we have x1 as 2 and x2 as 1. This will become positive. So our eigenvalue becomes, so eigenvalue will be equal to x1 will be 2 and x2 will be 1. So these are steps what we have done right now. Write or take any row from a minus lambda I just after calculating eigenvalue. Then we separate the variables, then we use cross multiplication, use cross multiplication procedure. Then it automatically generates eigenvalue. And this process is valid only for 2 cross 2 matrix. Now let us calculate for lambda is equal to 1 with shortcut method. We will consider a minus I into x is equal to 0, and our matrix will become 2 2 1 1 and x1 x2 equals 0 0. We will use first row as our equation. So equation becomes 2x1 plus 2x2 equals to 0. Now we can write, now 2x1 equals to minus 2x2 and x1 by minus 2, we will cross multiply x2 by 2. We will cancel out each other. X1 will be minus 1, x2 will be 1. Now we got our second eigenvalue. So corresponding to eigenvalue lambda is equal to 1, the eigenvector is minus 1 and 1. If we take x1 as k, then we will get eigenvector as 1 and minus 1, but minus 1 and 1 and 1 and minus 1, they both represent same vector. We will see through a graph. This can be x and this is y. This will be then minus x and this will be minus y. And 1 1, -1 and -1. Now clearly we will see, we will take a line, and what does our vector represent is -1, and this will be -1 and 1, which is -1 and 1, and this will be 1 and -1. So 1 -1, so they both represent, so this both vector lies on same line, therefore they represent same eigenvector.